Yeah, so hello. Um, Great, we will start on time. Okay. And for next 45 minutes, or 40, how many I have? Crypto is cryptography. Okay? So if you expected cryptocurrency, Bitcoin, blockchain, blah, blah, blah talk, there's a wrong room for that. And before we start, let's meet. So please raise your hands if you are a software developer. Right? If you're solution architect, software architect, whatever architect. All right. And security people. Offensive security, pen testers, security researchers, defensive security, security engineers, SecOps, DevSecOps. Great. So, just for your information, most people are developers, some people are architects, and we have pretty many security people here. And this talk is going to be a high-level cryptography talk, so no ciphers, no S-boxes, no formulas, and security design talk. Mostly we will talk about box and arrows. And we will build a multi-layered security defense around our data. So my name is Anastasiia, and I'm a software engineer. I was doing a lot of mobile development and then switched to security software engineering. And now I'm like kind of balance between a world of exciting modern cryptography and applied software engineering. I work at companies that called Cossack Labs, and this is a software vendor. We do data security, and we have this R&D and military crypto background, so we kind of want to make high-grade security available for medium companies and even for startups. And first, we thought that if we will introduce, modern, cool cryptographic tools in the market, developers will start using them and make their apps more secure. But apparently, it doesn't work this way. So we kind of shift focus from people to tools. And now we believe that even if you don't have security engineering team, but you apply correctly, okay, modern cryptographic tools, you can kind of lower the risk of security incidents and raise the bar for attackers. And today we're going to discuss defense in depth as a defense of data. And my slides are already online, and these QR codes is for slides. It's not a malware website. So this is for slides because I'll have a lot of schemes and a lot of links. And if you understand that cryptographic talk, security design talk is not for you, and you're gonna grab some coffee, just make a photo, feel free to go. I will remember your face, but still, it's gonna be fine. This is our plan. First, we will make a small introduction about modern regulations and about where industry pushes us in data security field. Then we will take a look at modern distributed applications, threats, and potential attacks. And we're gonna talk about defense in depth, how to build defense in depth in our apps, what tools to use, what things to read. By the way, have you read these books, at least one of them? Okay. Have you heard defense in depth before? Yes? No? Okay, so defense in depth, this is not a new term. Well, most security terms are not new. They came from military, from war. But in computer science, previously, defense in depth meant it was about network security, about transport, about securing transport in our intranet and in our networks. But now we are talking about defense in depth not only on network level, but on application level, on data level. And why? Why do we care about data security anyway? Well, I think it's obvious, right? We have like data security depends, your business continuity depends on how good you protect your sensitive and valuable data. Then we have regulations that push us, like GDPR, HIPAA, PCI DSS, all this stuff. And these regulations push actually service providers we use. So service providers push us to implement some changes. And of course, if we fuck up with data, our users will be a little bit angry, let's say so. But like, from my opinion, I really like users, but as much as I see in industry, companies don't really care about user data. So all these things affect more than what users will think about us, which is not good, but still. If someone says you, the GDPR is not about encryption, show them these articles. So Article 32, Article 35 is about how to process and store data securely. Article 33, 34, it's about how to monitor on data breaches and how to tell your GDPR regulator and your user what just happened. So these are articles about data security. For example, Article 32 says that taking into account the state of the art, blah, 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 you should use pseudonymization and data encryption. Black and white, GDPR. You didn't make things easier, right? Yeah, pseudonymization means that you use some nickname, like pseudonyms, in your data, so you kind of divide identifiable data from valuable data, right? And your users, you still have a lot of user data, a lot of personal data, but instead having like a real names, you have John Smith kind of names, so pseudonyms, okay? And GDPR doesn't say a lot about what kind of encryption we should use. However, US Department of Defense does. And they recently released this really cool guide about how to make software, how them, as Department of Defense, wants to make their own software to be able to move fast, but still to be able to create strong software. It's very interesting and suggest you to read, and the link is on the next slide. We are interested in principle number 9, which said that data should be encrypted all the time, except short moments where the data is being computed. Which means, in simple words, that TLS is not enough. Database encryption checkbox is not enough. AWS encryption checkbox is not enough. TLS plus database encryption plus AWS encryption are not enough. Data should be encrypted per user, per application, in a way that only those users or services that have this data can decrypt that, like end-to-end encryption way. Or if you can't build end-to-end encryption, only trusted services can decrypt this data, only for computational time, and then encrypt it again. Next is fun, Google. So if you use Google API to collect Google users' data, but you store Google users' data on your own servers, you will receive a happy letter from Google saying that now your company must do a security assessment because you store Google users' data. And you as a company must do the security assessment during 2019 for your own cost. And Google estimates this security assessment to cost between $15,000 and $75,000. But as a company, you won't pay Google. You will pay security assessor, the company who will make security assessment to you, not to Google. But Google, of course, will have at least some kind of trusted, security assessment companies. And I know some companies that already received these letters from Google. And basically, I don't know what will happen during this year, if they will make security assessment, if Google will push them out of, the API. I don't know, let's see what happens. But when Apple provided something similar, when Apple updated their data privacy policy, Apple actually starts rejecting applications that collect too much data. So maybe Google will do something similar. And of course, I'm sure you know this, right? OWASP top 10 web risks. Let's not stop here, it's all obvious. Last thing I want to tell you in the intro section, what kind of data we're going to talk when we're talking about data protection. These could be user data, like personal identifiable information, like likes, preferences, history, basically all kind of data, sensitive and valuable for you as a business. Even if you make something like Instagram for kittens, you still may have some valuable data not sensitive, not personal, but still valuable for you as a business. But another kind of data is service data, all this technical data that we often forget about. Logs, when we store passwords in a plain text, keys, accesses, API tokens, plain text backups, all these things are also data to protect. And each of these data class has their own risks. If we leak user data, this kind of compliance, legal and reputational risks for us as a business. If we leak service data, again, reputational and business continuity risks. Okay, this is end of intro part. And now we will talk about something more interesting. Cat information, if you can't identify cat, now according to GDPR, it's not. But if you store the cat home address, the thing is that users will use the application even if you as a company doesn't do security assessment. Right? Users kind of trust you to store their data, and it's your responsibility as a company, as a business, to do something about that. This is very simplified architecture of typical web apps, but it's okay to show the data flow. So data is gathered somewhere on web front end or mobile app, let's say so. The data is being computed on application backend and stored in some kind of database. So database is a final destination. Database, logs, files, whatever. We can also show it like a multi-layered model. And in this typical security scheme, we believe that attackers are only outside, that they need to pass through all this front-end, break back-end to get to the database. Or sometimes, and each of these components, they have like thousands of potential vulnerabilities. Sometimes there are attacks like SQL injections, like a hyperloop that allows you to jump from front end right to the database, steal your data, and jump back. However, in a real world, a lot of attacks are made by insiders, and insiders can be on each level. So when we are building security model, we kind of need to keep into account that each of these components can not only be hacked from outside, but also from inside, from like each level. But I mean, there are a lot of security people, there are a lot of developers here. We already know a lot of security controls. What could possibly go wrong? So all these letters are actually security controls or security principles or models or software. There is only one abbreviation that is not about security. Can you find it? Okay, so we as developers, as architects, we already know a lot of security controls, and we can put these like chaotic security controls into our infrastructure, like this. So we have means of active protections like firewalls, web application firewalls, data firewalls, like intrusion detection systems, host intrusion detection systems. Then like AAA, authorization, authentication, access control, right? Restrict access, create data policies for data. Then we have a lot of security coding. How we like application security, how do we code? We have a lot of dependency management tools that check if we have vulnerabilities in our dependencies. Then all these actions are covered by logs, by monitoring, by anomaly detection systems, by CMs, blah, blah, blah. And it's kinda works this way until it's broken. And this is what we call band-aid security model, because we kind of make a lot of bends to problems we believe they are. And many developers believe that these security measures, that they build security measures like perimeters. And the more perimeters they have, the better the system is. However, attackers, they don't think in perimeters, they don't think in checklists. They think something like a vulnerability path, like attack graphs. So they're moving inside perimeters one by one, checking for vulnerability each of these perimeters. And eventually, they will find a vulnerability in every perimeter, and eventually they will construct this vulnerability path and go and grab your data. And this, by the way, this is example of a tag graph, like a real one, pretty much old school one. Even if we have a lot of security controls, this is a tag graph. Each of security controls can have a lot of vulnerabilities. But let's get back to our system. What it means for us. We have an infrastructure, we put a lot of chaotic security control there, but we still have a lot of risks. Let's go back to SQL injections, right? We still have this risk of SQL injections going and grabbing the data. We still have these risks that the vulnerabilities on backends, like Node.js models vulnerabilities. Then like misconfiguration, even if we put this encryption checkbox on our AWS, but misconfigure our S3 bucket, make it public by default. Even we still have all these problems, and even if we have TLS as an ultimate security measure, sarcasm. So even if we have TLS, but we use weak ciphers, or we obtain certificate from unreliable certificate authorities, TLS in itself, it's not enough. Yeah, it's a good security control, but alone, it won't work. And here, the defense of depth, in depth, is idea that kind of want to help us to deal with this chaos. And I think at this point, we can turn the AC on. Can we, please? Yes. White button. Great, because I feel that it's already warm and we run out of oxygen. So, defense in depth. Ready? Great. Defense in depth says that, obviously, one security control is not enough. Chaotic set of security controls are not enough. You will get better results if for each risk or group of risks, you will build interconnected, independent set of security controls, kind of overlap security controls. For most, like for potential risks, for most probable risk, you will have more of these overlapped security controls. For not so critical risk, you will have less, but still, you're building a system that overlaps. And this is the principles. So defense in depth said that, okay, we have this infrastructure with chaos inside. We need to have some security control that works globally, that will protect data from all these components, all the way during the data flow. This will be our core level of defense. And then for components we know that are vulnerable, Node.js application backend, SQL database, we will put more security controls, like double and triple protection. Which layer is good enough to create this core defense layer? Of course, cryptography. When we use cryptography, we encrypt data all the way around, and we make the data flow predictable. Data can't be suddenly decrypted somewhere, right? To make data decrypted, we need to put some code or some server that will decrypt it. So we build this data flow. It's very clear when the data gets encrypted, when the data gets decrypted. And we know all these places where the data is in plain text. We can monitor these places. We can create more security controls on these places with plain text data. Authenticated encryptions ensure that the data is in plain text only in a few places, and it's complicated to change it without a notice. How to make this kind of systems? If you do mobile application development, or if you have mobile-based infrastructure or IoT-based infrastructure, you can do this end-to-end encryption, right, to build like cryptography all the way around. Unfortunately, if you do a lot of web applications or distributed apps, probably you can't have end-to-end everywhere. So the nice, handy pattern, which is called decryption proxy, will help us. I don't want to pay attention on, I don't want to stop and explain the architecture, like the architectural pattern itself. Decryption proxy, just kind of obvious. And we will jump again right to our infrastructure. So what has changed? We kind of have a separate service that is decryption proxy. It sits between application backend and the database. And we add the multi-layered encryption. Client-side encryption. By client, here we understand application backend or mobile app. Proxy-side decryption. So we have only one entity that can decrypt the data, which make our data flow very predictable. We have separated, we use like the separation of duties. We separated encryption and decryption. And now we have writing data to the database. Very predictable, like one way. And reading data from the database through decryption proxy, also kind of very predictable. I see it in your face. Like, what? Can we please go to something real? Okay. This is how writing process looks like. Application encrypts the data and stores encrypted envelopes in the database. I'm talking about database cell level encryption. So any blob of data you find sensitive or valuable for an app, any string, any piece of binary, you get encrypted on app side, and at the end it will stay in the database. Yeah? Wait. I will tell you everything. To read data from the database, you need to read it through decryption proxy that will decrypt it and gets back to the application side. And now answering your question, key model. So this is a hybrid encryption scheme. The application side only has key to encrypt the data, which is public key of decryption servers. So application can't decrypt the data. That's like super important. The decryption proxy has private keys, which of course is stored encrypted, and master key is stored somewhere in HSM, KMS, whatever you have in the infrastructure. But only decryption proxy has a private key, and which is not very obvious. Application backend can't decrypt the data. Database can't decrypt the data. Database doesn't know the nature of data. If you hack application backend or use vulnerable Node.js modules, it can't decrypt the data. If you hack the database, or you will have the plain text backups of the database, the data is still encrypted in these encrypted envelopes on database cell level, right? Data is encrypted. But encryption itself, of course, it's not enough. It can be broken, your keys can be stolen, someone like we told previously about insiders. So remember all these controls, right? Now we need to put again all these controls to our infrastructure, but in a little bit more smart way to make sure that we have this overlapped, double-checked and triple-checked around of data flow. Let's back to our scheme. So this is component that will encrypt the data, and then we need to make sure that we will have good transport layer encryption, so we will use TLS or any of available general purpose cryptographic protocols like TMS encryption or leap signal. Then, on this decryption proxy, it's a perfect place to keep an eye on the nature of data. So here we can have SQL firewall, here we can have intrusion detection system, logs, monitoring, a lot of controls that will double check. So if the backend application will be broken with some SQL injection, let's say so, you still have SQL firewall as additional security measure for the same data flow, for the same piece of data. If SQL firewall is broken, an application makes successful request to the database and grab this data, you still have this decryption proxy that need to have correct keys to be able to decrypt the data. So another layer of control. Then, of course, you know what is a normal flow for your application and what is anomaly flow for your application. You can put a special strings in your database, honey tokens. And if you understand that these SQL injections got to the database, returns the database response, our proxy has decrypted this response and found honey tokens in response, we have intrusion detection system here that says, oh, something bad going on, let's block this query. So basically for one thing, for one data flow, we have these overlapping security controls. And as I mentioned previously, database doesn't know the nature of data, can be hacked. Application doesn't have a way to decrypt the data, so it can be hacked, but it should be hacked in a very smart way. And data is being watched. Even if all the system is compromised, even then, we have monitoring tools, CM, and intrusion detection systems that will alert us that something going on. Yeah. The only way, the only correct way to get the data to read it in a legal way is through decryption proxy, or you need to compromise a lot of things at the same time and leave and remove logs, leave no traces in the logs. This is called defense in depth, and these are lines of defense around the data. Storage level encryption. And of course, when we build this large distributed system, we use different key pairs for different applications or even for different users in our system. So if some part of system is compromised, only these, we kind of limit the scope of a breach. Only these keys are compromised. And of course, we have all these security management shiny tools like key rotation, key revocation, access control, right? Storage level encryption. Then authentication, access control. Then transport encryption, like with this TLS or cryptographic protocols. And then audit logs, intrusion detection systems, CMs, honeypots, all the way around our data. For me, it looks pretty much like a log. So if you wanna remember something nice about this talk, remember that the lines of defense look like circles on a tree, but around the data. I know it's not very obvious, but still a nice image to remember. So defense in depth is when we have a global security control in our infrastructure, in our application flow, and we use cryptography for that. And a set of interconnected, overlapped, traditional, shiny security controls to double check and triple check the data. Okay, this sounds really fun. I know, a lot of theoretical things. Take a look on these cats, because now we will speak a little bit how to build these in your real apps. Yeah, cat photo. How you can build it? Of course, you can build everything from scratch. If you have a nice team, if you have security engineers, it's not rocket science, literally. You just need to implement a couple of security controls and make sure, I suggest to start from design, from security design. So think first, analyze, plan, then build and implement. Or you can use already made box solutions, like for example, Oracle. If you use Oracle Suite, you know that Oracle has not only the database, right, that in Oracle infrastructure there is TDE, transparent database encryption, which works as encryption and decryption proxy, just in the way I showed you. Oracle also has SQL firewall as one of these models. So if you use some stack that has all these tools, you can use this stack. Or if you like existing tools, if you like to build it from your own, you can use open source tools and build some kind of system on your own. Depending on the amount of security engineering power you have, you may build some things. For example, you may use Green SQL, this is SQL firewall, Lipsodium, this is cryptographic library, create your own encryption proxy, and use some of existing intrusion detection systems, CMs, and web application firewalls like mod security, for example. Or if you don't have power to build all these things like Lego, you can use some of the tools I showed you, for example, Accra, which covers SQL firewall, cryptography, decryption proxy, and intrusion detection system in a one, and connect it to CM applications and to WAF that you already use. So Accra is one of the tools that is open source. You can try, and you will cover these web risks from a WASP. So if you build wisely this kind of system, even on existing components, you can kind of be safe from many risks from a WAP top 10. Of course, you won't be secure, like 100% secure, because no one will be, but you will have at least a lot of security controls around the same data flow, and if some controls will fail, and they will fail, at least you will have other overlapping controls and monitoring system, alerting, anomaly detection system to tell you what's going on. If you use cryptography, you kind of save because you have a good global core encryption layer. Take a look on the Kitty slide, relax. This is the end of security talk. I see it in your face that you're ready for something new, so relax, you deserve a kitty. Okay. So the key points. First of all, security and data security, it's all about money. It's not that, I know, security people like to show you cool vulnerabilities they do, but it's all about money for your business. And regulations we have on the market, GDPR kind of things, regulations that start pushing service providers like Apple and Google, and these service providers starts pushing you, right? Then, so you need to do something about that, about data security, for example. For data security, there is a nice modern approach, which is called defenses depth, which is not new in the security world, but it's kind of modern for the data security, because now we have all this shiny modern encryption, which is fast and reliable. So using defense in depth, you're building a set of interconnected and independent overlapping security controls around your data, and you put several security controls for most popular attack vectors. You know them. In infrastructure, each kind of technological stack has their popular attack vectors. Then you use cryptography as a good core level of defense in depth, and then you put all these security controls you already know in your infrastructure. And there are a lot of ready tools that you can use, a lot of open source and free tools on different level. So depending on your capacity as a company, depending how many people you have, what is your stack, how many do you have security engineers, you can use a bunch of tools and create some things custom for you, or you can use some larger tools and box solutions that have, that handle everything for you. And I know that, oh my God, and I know that you like reading and watching security talks. I see it in your face. Like summer, long evenings, why not read about security? So I prepared a set of links for you. If you do, for these are security, data security for distributed applications. So again, the blog post about defense in depth, how to make better your backend data security, then about database leaks and injections and how to make your database stronger. And I really like talks and posts by Sam Newman, who speaks a lot about microservices. He has a really good information about transport layer security for microservices. So I really recommend his talks a lot. Then, if you're curious, I also do a lot of talks about various data security topics for different platforms, let's say so. So I will be happy if you find me or if you follow me on Twitter. And thank you for listening. If you have any questions, feel free. Thank you.